Hi students, problem number 16 in wave optics. In Young's double slit experiment, the separation distance between the slits is halved and the distance between the slits and the screen is doubled. The fringe width, new fringe width has to be determined. It's very direct and simple problem. Many times this question has been repeated in the competitive exams. So first we will write fringe width general expression. Okay. So fringe width beta. Beta is equal to lambda into capital D divided by small d. So in the usual notation, small d is the distance of separation between the two coherent sources, namely the slits. And capital D is always the distance of the screen from the slits. So what is given here? The separation between the slits is halved. So the new distance d dash is equal to original distance by 2. So this is halved. Okay, and the distance between the slits and the screen is doubled. So d becomes 2d. So new distance d dash is equal to 2 capital D, because it is given in the sum, it is doubled. So the new fringe width, okay, new fringe width has to be calculated. So new fringe width, let us use the symbol beta dash. So beta dash, using the same wavelength of light lambda into d dash divided by small d dash. So instead of a capital D dash, we have to substitute 2d. So this is lambda into 2d divided by small d dash is equal to d by 2. So this is d by 2. So this denominator 2 will come to the numerator. So this is equal to 2 into lambda into 2d divided by small d. So beta dash is now equal to 4 into lambda d by small d, or beta dash is equal to 4 times beta. So this is the answer we are getting. So 4 times when the fringe width is increased, means that is called as quadrupled. Quadrupled means increasing 4 times. Okay. So option D is the correct answer. I hope you must have understood well. Fine.